Welcome everyone. So let's study today a new concept, that is dew point and humidity. So from lesson heat, and this is part 3 video of this lesson for class 10th SSC. Student, before starting the new concept, let's revise the concept which we have studied in our previous video. So in our previous video we have seen anomalous behavior of water. So what was that? So here when the water is heated from 0 degree Celsius up to 4 degree Celsius, what happened? Instead of expanding, it will contract. Okay, and this abnormal or this exceptional behavior of water is observed only from the temperature 0 degree Celsius up to 4 degree Celsius. And the behavior of water between its temperature from 0 degree Celsius to 4 degree Celsius is called anomalous behavior of water. That means instead of expanding like other liquid, it will contracting. Now related to this concept anomalous behavior of water, we have one question that in the region with cold climate, the aquatic plants and animals can survive even when the atmospheric temperature goes below 0 degree Celsius. So how? So here in cold weather, when the atmospheric temperature starts falling below 0 degree Celsius, water at the surface of pond or lake initially, now cold weather, that means in winter season, okay. So the surface of pond or in lake initially at temperature above 4 degree Celsius begins to radiate the heat to the atmosphere, and so the temperature of water near the surface, it start falling or it will start decreasing. And when the temperature of water at the surface falls below 4 degrees Celsius, water contracts and its density will increase, and therefore it sinks to bottom. That means it will sink to the bottom of the lake or pond. And when the temperature of atmosphere falls below 0 degree Celsius, water on the surface loses further heat to atmosphere and gradually freezes into ice, but water below the ice layer remains at 4 degree Celsius. So this is how the nature this protects the aquatic life during the winter season. So alongside you can observe the diagram in the aquatic animals in cold region in winter season. Okay, so here you can observe at the ice layer, and below the ice, just below the ice layer, the temperature is 0 degree Celsius, and here at the bottom of the lake or pond, the temperature is 4 degree Celsius. Okay, and this is the ice layer. So this is how the aquatic life are remain they survive in the winter season or cold climate. Now next question related to this concept only. In cold regions in winter, the pipes of our water supply break and even rocks crack. So why this happen? So student, in cold region, as temperature reaches below 4 degrees Celsius, water instead of contracting starts expanding due to its anomalous behavior of water. And as temperature decreases from 4 degrees Celsius to 0 degrees Celsius, the volume of water increases continuously, and as a result pipes experience force applied by water and they will break. Now here one more picture is there in which you can observe the rocks are cracking. Okay, so as there is no room for expansion, it exerts a tremendous pressure on the rocks which crack and break up into small pieces. So as the volume increases, the water become contracting and they will break or rocks crack. Now let's study a new concept of this video, that is a dew point. Student, about 71% surface of the water of the earth is covered with the water, and due to the constant evaporation of water, water vapor is always present in the atmosphere. And the amount of water vapor in the atmosphere help us to understand the state of daily weather. That means this weather is humid, cold, or very hot or very dry. So the presence of water vapor in the air makes it moist, and the moisture which is there in the atmosphere, it is called as the humidity. So what is humidity? This is the presence of water vapor or the moisture which is present in the atmosphere. It is called as the humidity. So climate becomes humid. Alright, so for a given volume of air at a specific temperature, there is a limit on how much water vapor the air can contain, or the how much more or less the water vapor air can hold. So if the amount exceeds this limit, the excess vapor converts into droplets. And when the air contains maximum possible water vapor, it is said to be saturated with the vapor at that temperature. That means when the water vapor are exceeding than the limit, okay, then it is then the air is said to be saturated with the vapor at the particular temperature. And the amount of vapor needed to saturate the air depends on the temperature of the air. That means whether the temperature is less or more. Now if air temperature is low, it will need less vapor to saturate the air. And for example, if temperature of air is 40 degrees Celsius, which is more, it can contain 49 grams of water vapor per kilogram of dry air without condensation. Now condensation, in which gas is converted into water. And if the amount of vapor exceeds this limit, the additional vapor will condense. Now, however, if the temperature of air is 20%, it can contain only 14.7 grams of water vapor per kilogram of dry air without condensing. And if the vapor contained in air is less than the limit, than the maximum limit, then the air is said to be unsaturated. Now here we have seen the two conditions, that is saturated air and unsaturated air. So the saturated air, in which the maximum amount of water vapor air can contain, so that is air is said to be saturated. But in the unsaturated air, we have seen the water vapor contained in air is less than the maximum limit, then it is then the air is said to be unsaturated at that particular temperature. Okay, now suppose the unsaturated air at a certain temperature is taken. Now unsaturated air means the air in which the less water vapor are there. Okay, so suppose the unsaturated air at a certain temperature is taken and its temperature is decreased. So what happened? Our temperature is reached at which the air becomes saturated with the vapor. Now saturated means in the air in which the more amount of water vapor are there. So this is the dew point temperature. Alright, so the vapor content in the air is measured using a physical quantity called as the absolute humidity, and the mass of vapor present in a unit volume of air is called the absolute humidity. And generally absolute humidity is measured in units like kilogram per meter cube. And it means that the feeling of humid or dry nature of air not only depends on the amount of vapor in the air, but it also depends on how close that amount is for making the air saturated with the vapor. That means how close the unsaturated air is converting or making the air saturated with the vapor. And this is nothing but our dew point temperature also. And it means that it depends on the temperature of the air also. Now here we have the relative humidity. So the ratio of actual mass of vapor contained in the air for a given volume and temperature to that required to make the air saturated with vapor at the temperature is called the relative humidity. So here you can observe the formula for percentage relative humidity. So percentage relative humidity is equal to actual mass of water vapor contained in the air in a given volume upon mass of vapor needed to make the air saturated. Okay, saturated in that volume multiply by 100. So as this is percentage, so it will multiply by 100. Alright, so the relative humidity at the dew point is 100%, and if the relative humidity is more than 60%, we feel that the air is humid. That means air contain moisture. And if the relative humidity is less than 60%, we feel that air is dry. Alright, so during winter season, a white trail at the back of a flying plane in the clear sky. So I hope you all have observed in your lifetime. So as the plane flies, the vapor released by the aeroplane engine condenses and forms clouds. So condensation, in which the gas is converting into liquid state. Okay. And if the surrounding air is having more relative humidity, it takes a long time for the white trail formed by a condensation of the vapor to disappear. And if relative humidity of surrounding air is less, then either the size of the white trail may be small or it may not even get formed. Alright, now here we have we have an observation like take a bottle of cold water out of a refrigerator and keep it outside for a while and observe the outer surface of the bottle. So if we are removing a water bottle from the refrigerator, we have seen the droplets of water outside the on the outer surface of the bottle, right? And the second case, the drops of water can be observed on the outer surface of the bottle. And the same way, if you observe the leaves of plants or grasses or window glasses of vehicle in the early morning, we see water droplets collected on the surface, which we may call that dew also. Okay. And through these two observations, we sense the presence of water vapor in the atmosphere, and when air cools due to decrease in temperature, it becomes saturated with water vapor, and as a result the excess water vapor gets converted into tiny droplet, and the dew point temperature is decided by the amount of vapor in the air. Now let's understand the unit of heat. The student, the unit of heat are joule, symbol is J in SI unit, and calorie in CGS unit. And the amount of heat necessary to raise temperature of 1 gram of water by 1 degree Celsius from 14.5 degrees Celsius to 15.5 degrees Celsius is called as a 1 calorie heat. And similarly, the amount of heat necessary to raise the temperature of 1 kg of water by 1 degree Celsius from 14.5 degrees Celsius to 15.5 degrees Celsius is called as a 1 kilocalorie heat. And it is clear that 1 kilocalorie of heat is equals to 1000 calories. So that's it for today's video. Student, I hope you all have understood all the concept I have taught in this video, and next part of this lesson will continue in our next session. Let's say thank you.